So on www.hack23.com, you could access some of the resources I will use in this presentation. And you can also see my GitHub link and also my link to LinkedIn. So a bit about me. I've been active in open source for a long time. This data is from OpenHub that tracks open source contributions to different projects. So I think I've been active for about 15 years, contributed about 8 projects, among them like Yeti, some people probably know about, and also Java Melody, Javers, it's an auditing framework. Some other analytics from also tracking my source code. You could see that when it comes to open source, I'm most active in evenings and nighttime, and most productive on Sundays. So, and a bit about my preferences. So I would say I prefer Eclipse over IntelliJ. Not sure most people agree with me. I see a lot of young people using IntelliJ. I don't really understand why, but I also prefer Maven over Gradle and Linux over Windows. So during daytime, I work at Wirelesscar that presented here earlier. I work as a security architect. So mostly work with the security and compliance in the cloud. And I've been using Java for about 20 years and AWS for about 10 years. So this is about security and why do we need to do security. I like this commit strip. It sort of explains early in the project, people want to do security, but it's not the priority. Later in the project, the company doesn't have a budget, and then people are worried, and then they get surprised that they get hacked in the end. So who is responsible for security in the project? This is from a Snyk report that asked a lot of open source developers who is responsible for security in the project. So a lot of people think the security team, more people think that developers, operation. I don't like the last answer, it's nobody. So how do we add the security to a project? So most of them try to add some type of security testing during CI. So I think the most common one is we do some type of static code scanning of our source code. And we might analyze the vulnerabilities of the dependencies that we use. And here they also talk about scanning Docker containers. I won't talk about that part. And I think also missing from this report, how do we test our running application? That's normally called dynamic application security testing. So the agenda, I'll talk a bit short intro about how we track bugs or issues in software, a bit about DevSecOps, a bit of different types of security testing, secure development pipelines, and Sonarqube that I will use in this presentation, and a short demo at the end. So during this presentation, I will use my own open source project called the Citizen Intelligence Agency. Its slogan is tracking politicians like bugs. It runs currently, compiles with Java 11 and possible runtimes at 11, 12, 13, and the latest build of Java 14. So since how many started to test with Java 13 that was released yesterday? Anybody? So here it's some link to the Sonarqube instance, link to the source code, and also a running demo of this application. So how do we track bugs, or specifically security bugs in this? So there are a lot of standards, so I just want to mention them quite quickly. I won't go that deep into the different standards, but so type of bugs, it's a common weakness enumeration, or CWE. It's a category for system of software weaknesses and vulnerabilities. It's maintained by Mitre, but it's supported by the US Department of Defense, and some other government organizations. And SANS normally maintains a list of the SANS top 25 most dangerous software errors, and it's using these CV categorizations from before. And also another quite common top 10 list is most critical web application security risk. Also a link here. And when it comes to known vulnerabilities in dependencies, I will talk more about dependencies and different reasons why we need to track dependencies later. But it's common vulnerability exposure, and each vulnerability contains a CVE number, and it's also categorized by risk from 1 to 10, where 10 is the most severe risk. Here's some links to this list that are maintained, and also an example calculator how you could calculate your own risk. It takes into account how easy it is to exploit, and sort of the risk, what happens when an exploit is done. And also worth noting that for all dependencies, not all security issues will have CVs. It's mainly for large companies and large organizations like Apache, Eclipse, a few others that apply for these CVM numbers. It's quite a hard process, or if you're using open source project maintained by individuals or smaller groups, they probably won't create CV number for the vulnerabilities. You probably just add it to a mailing list or in the release notes. So that's one of the reasons why it's important to patch your dependencies often. So this is a good DevSecOps reference. It's produced by US Department of Defense, was released 2 weeks ago. And it talks about how you could include security in all parts of the life cycle. So I've used some of the slides from there. So here I want to add some, during planning of a project, I want to do some probably risk analytics, and then doing development, doing build, doing test. So during the whole process, I want to add different types of security activities and probably some control gates to stop software going out into production where it doesn't pass security gates. So here it's a similar part that look at different type of activities during the life cycle. So you see at the build, you have a DAST, SAST, and so we talk about these type of security tests. Just want to, you also see that during operations, if, for example, you have an activity security patch, so maybe you need to patch your systems on a regular basis. So this is type of security test I will talk about today. So static application security test will scan your source code, software composition analytics, different types of scan your dependencies, and dynamic application security test DAST will scan running application. So static application security test SAST will scan your source code, and there are a lot of different tools available. And the benefit of this is that the application doesn't need to be deployed and running. So some questions that SAST probably will answer, the different tools. So how much code is in the project? Is the code tested? How much of the code is tested? And how many potential issues can be detected by scanning the code? So a few alternatives for scanning code. Most of you, I will use Sonarqube this presentation, but most of you probably know PMD and findbags and checkstyle. They are more de facto standard. They've been around for probably 15, 20 years when it comes to scanning Java code. And they have some enterprise versions, checkmarks, Coverty, and IBM Security Scan. And if you run your project on GitHub and it's public, you have a few other options. You can run SonarCloud, it's hosted Sonarqube. You could run Betty Code Hub, CodeBeat, Looking Good to Me, Code Climate, CodeOC, Code Factor. And all of these are really good if you run a public, your own projects on GitHub, because they're all free for open source projects. So next we talk about software composition analytics. So it's a quite large area, but we will cover like component inventory, known vulnerabilities, outdated components and licenses. But I think this area also includes, for example, if you want to use a new library, you might have to look at the community. Is the community healthy? Has it done any recent releases? Is the code maintained? So basically, if I start to use this software, will I get the support when I go live in like another 2 years or something like that? So when it comes to Java, most of you are familiar with maven repository or different type of repositories, but the number of dependencies in the Java world has increased a lot. So say that you have 40 million, maybe half of them are shitty projects, but the rest might be useful. And if you look on, this is also from the SNCC report, if you look on the trend when it comes to different ecosystem about known vulnerabilities, it's sort of, yeah, known vulnerabilities are found all the time, and it's sort of a never-ending quest of trying to avoid them. So the most reason it's important to update dependencies, I mentioned before that not all dependencies will have CVs, but it's also that if you stay up to date with your dependencies, you're like maintaining up-to-date dependencies is sort of a subset of general updates. And this is also, it's from a report, the Sonarqube State of Supply Chain. It talks about time to remediate and time to update. Time to remediate in this case is how long does it normally take before you fix a known security vulnerability among your dependencies. And time to update is how long does it normally take to update a dependency. But you see it's a nice relation. You see that these checked about, I don't know how many, but it checked a lot of the open source projects that were on GitHub, and you can see that are, so some projects are quite fast, but a lot of projects, and maybe a lot of these projects are not maintained, almost never fix any dependencies. It might be that they don't release any new versions. And next thing about source component analytics, it's about licenses. So the basic question is, if you add a new dependency, are I even allowed to use it in my project? So I think that's, if you're not allowed to use it, you don't need to care about updates or vulnerabilities. So I just want to mention, you have the trade secret proprietary. So most of you people probably work with creating proprietary licenses of software, but you use some open source code. And when it comes to open source licenses, you have a subtree of permissive licenses. They're based on public domain, so it's free to use, and you can basically do whatever you want with it, even include it in commercial projects and sell them. And same with the weekly protective licenses. They're mostly done for libraries that they want people to include. But if you start to include strongly protective dependencies, you probably have an issue. And if you use a Pether GPL or now, I think Mongo public license as well, you will have problem even if you just release your software as a service. So questions SEA will answer, how many and which dependencies do you have in the project? Are you allowed to use the project's license or compliance issues? Are there any known vulnerabilities and security risks with your dependencies? And do the project have any stale dependencies, and how outdated are your projects? I had a discussion with somebody converting from Wildfly old versions before, so that's probably not the best scenario. So when it comes to SCA, you have a lot of alternatives. Probably you could use for known vulnerabilities, you could use dependency check maven. It's also available for Ant and Gradle and command line. So it's basically checking your dependency against these CV lists that I showed you before. You also have Sonarqube. You have a few commercial ones, Snook, depending about Black Duck. I think Black Duck is probably the most common commercial ones here. Nexus Deep Shield and Nexus IQ server. It's part of Nexus to check your security vulnerabilities in Nexus. And when it comes to licenses, you see Sonarqube here again. You could use Maven license plugin. I know there are plugins in Gradle and Ant to manage licenses as well. And also use Fossa. It's free for open source, so it works well if you have a project on GitHub. And Black Duck also covers licenses. Black Duck is even better. It even detects if you cut and paste some code from Stack Overflow or something like that. And dynamic application security testing checks your running applications. So you basically have a lot of active or passive scanners. Passive scanning is just trying to invoke the basically HTTP request, but active scans try to inject the malicious content into a request. So it requires a deployed and running application, so it normally ends part of later in the life cycle. And when it comes to DAST alternatives, you have a SED attack proxy, W3 AF, Arachne. You have a few commercial ones, Unix, Detectify, Qualys. I think Detectify is actually Swedish, so it's a SAST solution as well that you use. So why Sonarqube? Since I have background in open source, it's totally free to use if you use the community version and only stay with the open source plugin. There are enterprise versions and also commercial plugins for it, but it covers many use cases. And I think it's good because it aggregates result in one place and promotes transparency, accountability, and enforce policy. You can also manage issues. A lot of the common problem with all the tools I talked with before, they have a quite large amount of false positive. So things that are flagged as issue but are not really an issue. So it's good to be able to handle them in a central place. But I would say for many, if you only have like a few projects, you could probably set up like a secure development pipeline with Jenkins, Maven, Gradle. So for example, Jenkins has a lot of plugins for this tooling as well, and say with Maven and Gradle. So I choose to use SAP or SED attack proxy in this presentation, and it's easy to run. They are provided with the Docker, running Docker containers, and they also has a plugin to get my reporting into Sonarqube. So this document contains to support two use cases. Both you have a SAP full scan that's suitable for web applications, and you have a API scan where you just need to provide it with like a Swagger definition for your API and some type of authentication token if it's secured. So here I have a basic continuous integration pipeline where I do compile, test, I do some security scan, I scan my dependencies, I scan for update, I could start the application, I could do security scanning of the running applications, stop the application, and then publish the result. And if you have like a pipeline where you actually deploy things in the cloud, here you can see that build and publish QA result is part of the pipeline from before. But then you could, for example, fail your project if your quality gate, I will talk later about quality gates as well, but before you're actually setting up like a complete cloud environment, and once you set up a cloud environment, you could do some type of performance testing, some system testing, or you could check, for example, here I check for SSL labs that verify that my SSL config are correct. And here I actually run the SAP as a security baseline test again at the end. And then I tear down my cloud environment. So I'm trying to demonstrate how you would run this with Maven. I think if you use Ant or Gradle, it's probably similar. So I'll start with just just need to mention that if you add config in your POM XML, this would be a lot simpler. I just want to clarify it, for example, without having to go into a POM. So first step, I run, I build my project, but I add the Javaforum test coverage. Then I run my OWASP dependency check that will check for known vulnerabilities. Then I create a report for dependency updates available by my project. And then I would start my application with Yeti start or Spring Boot start or something like that. And then I could, with the Docker, run my full scan of against a web URL. And here I also specify that I want to use Chrome ID for like IX spider. If you have like a single web application in JavaScript, you probably need something like that. And if you have an API, you could run the same similar test, but with against the SAP API scan. But here you need to specify your Open API or Swagger definition. And then I stop my application, and then I just publish all this data to Sonarqube. So, see if I could go and so just talk a bit more about Sonarqube. Sonarqube supports probably about 20 different languages and has about 100 around plugins for different types of use cases. And the quality model, it will detect bugs or code that are likely to yield wrong behavior. When it comes to security, it will detect potential vulnerabilities, and it will also identify security hotspots. And security hotspots are not code that are detected as wrong, but it just identifies code that are sensitive. For example, if you use authentication annotations and stuff like that. And when it comes to maintainability, code smells are basically code that are not conforming to convention and standards. See. I just won't go into detail. How Sonarqube works. So basically, you could run your scanner for Maven, Ant, Gradle, against your project, push it to the Sonarqube server, and it maintained all the data in a database. And here it's a more complete integration. So you normally have some type of continuous integration server that access your code from Git, CVS. CVS, it was a long time ago, but maybe some people still use Subversion. And Sonarqube also have ID support, so it supports IntelliJ, Eclipse, Visual Studio, VS Code, and here you could analyze your code in your IDE before you commit it to your source code management. And Sonarqube, it's open source, and the latest 7.1 version, it's long time support, so I think it's supported for another 2 years. It requires Java 11 runtime, but you could run your scanners with Java 8 and above. If you have all the code than that, you probably need to go to the Sonarqube 6.7 version that used to be the last LTS version. So just some links. So link to Sonarqube and some of the plugins I will use in this presentation, like the SAP Sonar plugin, dependency check, Sonar plugin, Sonarqube license check, and also dependency updates. So I just want to talk about some concept before I demo the project. So Sonarqube are rule-based. It contains a lot of different types of rules. So here I look at the different type of available rules that they have, about 5 for Java, about 500-600 bug detection rules, about 170 vulnerabilities, a lot of rules for code smells, and currently 32 rules for security hotspots. And these rules, if they detect this type of patterns in the source code, will raise different type of issues with the severity level. So you have a blocker, critical, major, minor, and info. And the reason I talked about the different ways of tracking bugs before is that most of the vulnerabilities and security hotspots are classified according to OWASP, SANS, CV, and CWE. And Sonarqube also introduced a lot of metrics on the project. So they have these reliability, security, maintainability ratings, but you can also see coverage, application size, complexity, dependency updates, and vulnerabilities. I will go into this a bit later. And one thing I like about Sonarqube is that you could introduce quality gates. So based on these metrics before, you could say that I only allow projects that don't have any critical security issues, for example. And another way you could structure your quality gates, you could have like a minimum level that you accept in a project. You could have a recommended, good, or excellent. And then you could here set different thresholds on different type of these metrics and measurements that you get from before. So I just prepared this slide for the demo, but I thought I would actually use my project here instead. So here on the entrance page, you get a summary of the number of projects, how many bugs, vulnerabilities, code smells, and security spot you have in total. And if you click here, you will get, you get like a basic list view, and we also get on the left-hand side here a lot of filters. So I could look at just projects that failed my quality gate. I could look at projects with E severity level when it comes to security, and or if I want to look at subset when it comes to test coverage or applications, size, different type of languages. So here you see A rating for bugs, E for vulnerabilities, code smell, and you also see the test coverage, a number of applications, and how much code is in this project and what type of languages there are. And here you see the reason why my quality gate at the top. So I have one blocker issue and I only allow 0 blockers, and I have 83 vulnerabilities, I'll only allow 10. And if I go down here, you can also see that it maintains a delta from our last release version compared to, so I could set different types of quality gate based on new code versus existing code. And is it code coverage, applications? So I just go to measurements that I showed you before. So stop here, if I look on code coverage, see if I go down a bit. I would say for most projects you want to be in the left-hand circle, so you have code with low complexity that are well tested, and I think I will start with So here, if I look for example, I get some metrics for dependency updates. Probably make it a bit larger. So we get a value for how many dependencies I need to patch, my patch ratio for my project, how many potential updates when it comes to major version. I have also upgrade ratio, rating for patch management, number of patches missed and upgrades missed. And I will just go to another view here. So I will get these ratings, and if I look at my security issues here, just need to choose. So you can choose to look at a subset of your rules. Say, for example, for one of the reasons I get a lot of issues that I have a lot of modules that use the same type of dependencies. Say, for example, define that I use Hibernate Entity Manager version 5.4.4, but there exists version 5.4.5 that I haven't patched. And just want to find one of the other ones as well. So we get one issue per project that actually use them, but sorry. Here, I'll show them too. So here you see that I also have a Jackson data bind version 298, and the next version is 299, but the latest version is 210.0. And the reason I want to talk about this one, if I look at my vulnerability report here, on the more, I will see if when I look at my known vulnerabilities, you see that it actually detected this version as vulnerable, and when it comes to the CV count, it has 7 known vulnerabilities, this Jackson version. And if I go further down, I will see some more detail about this version. So this is basically just references to the CV data, and I will know what identifier of a project that is vulnerable. I could get some more data about the vulnerability and more links to the CV. So this is just basically because I imported the report that I generated with the robust dependency check before. But I will also get, if I look on security issues, just need to filter on that rule. So it will also create, here it creates a blocker issue because it's the severity of this issue depends on the severity of the CV numbers. And here you see that I have 1, 2, 3, 4, 5, 6, 7 non-vulnerabilities this version. So I think this in combination with the dependency updates, just by maintaining your dependency up to date, you will save yourself a lot of known vulnerabilities in your dependencies. And then we also have, see if I could log in here actually. So next thing we will look at the licenses, but to be able to determine what licenses you actually allow in a project. Under administration here, you have a list of already imported licenses. And you could, for example, here set if you want to actually allow it or not. So then it will check this white list of licenses against your project. And here you also get a list of all your dependencies, and if you're allowed to use that license based on your whitelist of dependencies. So maybe it's like, I guess most companies probably have somebody that know more about licenses or what compliance you have to follow. For example, if you buy software, you could add that as a commercial software license, and you could also, for many projects that doesn't specify a license, you have the ability under license check to actually add a regex and say that this has a specific licenses. So you see that Netty, for example, is a quite common library. It could be the reasons that they use Gradle and not Maven, probably, that they don't have a license specified in the POM, and some projects have a license specified in the POM, but it doesn't follow the standard convention how you normally name that license. For example, you could use Apache license 2, but instead of writing Apache license 2, probably some people just write APL 2, and they mean the Apache license, so you might need to do some checking and add a few cases that are missing. So, see if I had. So we talked about updates, licenses, and vulnerabilities. So one thing we haven't talked about is dynamic testing. So normally when you run said attack proxy, it will generate a report with high, medium, low information level issues. And since it actually contains, like all of these tools do a lot of false positive, it's good to have a way of be able to close issues that are not relevant. So if I go back here again to my project, if you look on the vulnerabilities again, and if you look at a specific rule, you see here I have some SAP rule says that my content security policy header is not set, or my browser XSS protection is not set. And in this case, it's actually trying to detect my robot's text file, so it might not be that important. Then I could probably resolve that as fixed, as false positive, or if I want to fix it or have any actions. So I think this is one step better than having to review HTML report every time you run it, because you might have already decided these issues are not relevant. So I will actually go. I just added a few screenshots in case I didn't have internet, so I didn't know about the internet situation. So here, if I look on I just want to mention a few other tools. So if you look on my open source project, you see that I have a lot of badges here. So this license scan badges is from FOSSA. So since a lot of these hosted tools are free for open source project and public GitHub projects. I just added as many as I could to test and evaluate different tools. So here I see that my license scans, I can see that my contributor level agreements, 3 people signed. You can see my latest version in Maven Central, some badges from Jenkins and Sonarqube. And you'll see that I use code factor, code quality, I think it's code climate, better code beat, code quality, and also black duck. You see also black duck detected that I had the Jackson vulnerability. This is a badge for Nexus Deep Shield. It should have detected I had the Jackson vulnerability, but it didn't, so it's a shitty tool. And also here you see from Fossa some more data about the open source license I use. I think this Fossa is pretty good because it also defines what type of obligations I do have from these 32 different types of licenses I use. And here's another tool, Code Scene. They get some other type of data. So I think it's, if you have projects on GitHub, it's, I would recommend just enable as many of them you could actually, because it's, at least you get some content that Google could index for your project. And also when it comes to dependency updates, I mentioned a few tools before, but if you look on pull request here on this project, you see that a lot of these dependencies that are detected in my dependency updates, I have a dependabot that already created a pull request with this fix. It also detected Java's released a new version 8 hours ago, probably before I built my Sonarqube report. Protobuf has a new version. AVS have a new version. And I also got some fixes from Snookbot to resolve my Jackson vulnerability. So if I look on this one, I could see that you just updated the dependency, but if I look further down, I'll see that dependabot, even without knowing that the dependency had a vulnerability, just wanted me to update the project. So either of these options would solve my security vulnerability. So I think I choose this one. I'll probably have to go up. So now merge the fix, and hopefully after a while, Black Duck and other tools will detect that my project has been fixed. So any questions?
Dependabot that you showed now?
Yeah.
Also completely free?
Yeah, so if you look on the marketplace here, if you have projects on GitHub, if you go down to security here, you have a lot of these tools, and they're actually free for public GitHub projects or open source projects. So here you Dependabot, you have Snook, you have a few others. So I would recommend starting using bots if you have GitHub projects where you could use it. I think with all of these tools, even if you use just to find bugs, something, it will generate a lot of issues. So I think it's a good way of being able to disable different type of rules or start with a limited set of rules. So for example, if I look on my, just want to show you my Sonarqube instance here. If you look on the quality profiles, So here you have different type of profiles that you could use for enable different type of rules. So my CI rules has about 1,400 rules, but you could start with maybe find bug security audit or find bug security minimal if you have a lot of issues. I think it's also good to focus on the high severity issues first, and you don't need to care about like styling issues or formatting or stuff like that. And I think also another important question is when it comes to dependencies. I've seen a lot of projects that added dependencies that are not even used. So it's a good thing to actually remove them first. I will send these presentations to Richard so he could upload it on the Javaforum. So it do contain some links. For example, I would recommend this Department of Defense DevSecOps Reference. It's really useful. It talks about a lot of this type of testing, but in an abstract way without specifying any tooling. But it's a good to understanding the vocabulary.